Hello everybody. Let's put the fundraiser thing on.
Hello everyone, I'm David D. Hilster, President of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. Both years we have been successful in that the monies collected have been enough to keep us afloat. This year is our third annual online fundraiser, and once again we are counting on your support. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CMPS afloat. Hopefully, as we continue to grow, we will be gaining more and more automatic memberships so that these fundraising events won't be necessary. But we are not quite there yet. This year, we will be implementing several changes to our online system, several to save money and lower our annual expenses, and another to better our discussion platform. First, we will be moving our websites and databases to another server that has graciously volunteered to host us at a much reduced rate. It currently costs us $1,400 a year for our dedicated server, given that we need complete control over our own software. The new server will give us and allow us that control, but only for $250 a year. Second, we will be moving away from BuddyPress, which is a Facebook-like plugin for WordPress, to using Discourse. BuddyPress was an interesting experiment, but the upkeep of the plugin and its general design don't really fit what we need. What we need is a robust and well-accepted discussion forum, and that is why we'll be moving our online discussions to Discourse. It costs $20 a month, which is half the price of BuddyPress. I think those currently active in our online discussions will find this new platform much more enjoyable and functional. Third, we are moving to a free version of Overleaf, which eliminates a $33 monthly fee. Overleaf was useful for us when we were publishing our own proceedings for conferences, but that is no longer needed. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. To donate, go to fund.naturalphilosophy.org. That is fund, F-U-N-D.naturalphilosophy.org. Thank you, and keep up the amazing work that is driving science forward.
Well, hello everybody, and welcome to another Saturday session of Chappell Natural Philosophy Society. And once again, we're going to start complaining about Einstein's relativity. This time I'm coming at from the perspective of logic. Right, so I'll put my slides up. Hopefully everybody can hear me all right. Here we go. So today's question is, does Einstein's relativity violate logic? So you just hold on a moment, I'll check to see if it's coming through properly on YouTube. Is that, yeah, it seems to be coming through okay on YouTube. So, does Einstein's relativity violate logic? Question mark. There are many papers by relativity dissenters that point out Einstein's relativity violates logic. But those people who believe in Einstein's relativity don't accept that. They just think that Einstein's relativity does not violate logic. So we'll look into some of those issues. The papers by the people dissenting with relativity are such ones as this, by this person who points out there's logical fallacies of Einstein's theory. There's quite a few of these papers out there on the internet now. So if we look at logic, it goes back to about Aristotle. Anything that happens too far back and we don't really know. So logic really seems to start with Aristotle as far as we know. So you can ask a question like, well, we can make a statement which is all men are mortals, followed by another statement, Socrates is a man. And so the conclusion from those two statements, if those two statements are true, is that Socrates is immortal, and like all mortals, he will one day die. So the problem might be that there is classical stroke traditional logic which existed before Einstein. So when people try to make sense of Einstein's relativity from that logic, it does not make sense. When post-Einstein, there seems to be a logic developed to deal with Einstein's relativity, i.e. with all the other changes that came about with Einstein, there's also a logic revolution ? It's one of the things that winds me up is when defenders of Einstein's relativity say things like this. They say, Einstein wasn't wrong and his theories are simply incomplete. And by that, I'll give an example of a person who's saying that is a physicist. And to be incomplete means to me that it's wrong. But they're sort of like saying Einstein's relativity is not wrong, it's incomplete. So they're trying to have the word incomplete mean something different. She admits to Einstein's relativity being incomplete, but she does not want to accept that Einstein's relativity is wrong. And so that's one of the defenses the defenders of Einstein's relativity have. If you can point out to them that Einstein's relativity is wrong in some way, they won't accept that. They will instead say Einstein's relativity is incomplete and try to use the word incomplete to mean something different to being wrong. So for the two states of theory, it can be right or it can be wrong. They want to add a third state that it's incomplete. Now, by usual logic, you can either say something is yes or no, right or wrong, but that gets replaced with a theory can be right or wrong or incomplete. So you get three states instead of two. And so traditional logic is based on two states. So to save Einstein's relativity, it gets changed to logic to dealing with three states. So if you're a person and you're from a point of view of logic, something has to be right or wrong. That's two states. And they want to replace it by three states, where the logic should be right or wrong or incomplete. And by incomplete, they mean it's neither right or wrong. It can be partially right and partially wrong. And this same sort of thing gets extended to quantum mechanics. From the traditional point of view, you would say that the cat is either dead or alive. But it's sort of like with quantum mechanics comes along, it wants to introduce a third state where the cat is neither dead or alive. It's not until you look in the box do you decide whether the cat is dead or alive. So that's a three-state logic. So moving on, stating the issue, the problem might be that there is classical logic which existed before Einstein, and now we have a logic based on Einstein's relativity, or logic which is being created to deal with Einstein's relativity. And that might be the problem with people are trying to understand Einstein's relativity. They look at Einstein's relativity from a logic point of view, which has a theory can be right or wrong, but they don't have a logic where you have the third option. So now I'm going to use AI, which is artificial intelligence, to do most of the work for me. With AI now coming out, you can start to be lazy, let AI do all the work for you. However, you have to be careful using AI, because if you don't phrase the questions correctly, it will give you, well, from my perspective, the wrong answer. Because if you sort of like input into AI, ask the question, is Einstein's relativity does Einstein's relativity not does Einstein's relativity violate logic? The AI will defend Einstein's relativity and answer no. And so to bypass that, you've got to ask it more specific questions. You've got to try to get from AI what it means by logic, and whether it's talking from this vague way of changing logic from the 2 states to the 3 states logic. So you've got to interrogate the AI to make sure you get some sensible sort of answer. So traditional logic is often referred to as classical logic. It's a system of reason that focuses on principles of valid argumentation, formal structure, and the relationships between propositions as statements that can be true or false. And you note that it's given the 2 possibilities, a statement can be true or can be false. It doesn't give you the 3rd possibility of statement can be incomplete. And this logic has its roots in ancient Greek philosophy, and that's particularly, as I said, by Aristotle. And it can be split down to these sort of things: propositional logic and other things like that, and the predicative logic. So what you're talking about is a specific logic system based upon 2 states. And 3rd thing it has in this list is it's got the law of the excluded middle. The law states that for any proposition P, either P is true or its negation, not P, is true. And the 3rd option is the excluded middle. So you've got a logic system based on 2 states, and there isn't a 3rd option. It's either true or not true, and it's not a 3rd possibility of being incomplete. And also you've got these other laws. You've got the law of non-contradiction and so forth. And you've got to say about whether you have a valid argument or a sound argument in all of this. And so traditional logic has played a foundational role in the development of mathematics, philosophy, computer science, and linguistics. It's focused on ensuring that arguments are structured in a way that guarantees correct inferences. In contrast, and this is now pointing out there's a different type of logic to the traditional logic. In contrast, it's saying non-classical logic, such as fuzzy logic, modular logic, or intuitistic logic, may modify or reject some of these classical rules to better handle uncertainty or other complexities. So you've got this traditional logic, which is based on 2 states of right or wrong, yes or no, and then you've got these other logics which are going to be different. So for the traditional logic, I want to concentrate on this, which is the law of excluded middle. So in traditional logic, you've got this law that there is an excluded middle. You can either have a statement is true or it's false, and you can't have a 3rd option. There is other issues inside traditional classic logic which you could bring up in regard to Einstein's relativity, but this would be too big a subject, and so I'm just concentrating on something as simple as this law of the excluded middle. Those following Einstein's relativity and quantum mechanics seem to have, among other things, abandoned the idea of the excluded middle. So So that's what I'm pointing out. They bring in this third option of the theory can be incomplete. So the type of question I'm asking the AI, artificial intelligence, is classical logic is based on the law of excluded middle. Explain how Einstein's relativity violates that. And so as I pointed out, if you say that does Einstein's relativity violate logic, it will say no. But if you focus in a bit more on the issue of this law of excluded middle, AI will sort of admit that Einstein's relativity violates that. And so it's admitting that it's not going by, admitting that Einstein's relativity is not going by traditional logic. So if you were to phrase the question differently, suppose saying Einstein's relativity violates classical logic, then our AI would just try to defend Einstein's relativity. And when it says, Einstein's relativity extends classical logic, extends as far as I'm concerned means changes classical logic to something else. So extends, changes, or abandons classical logic, and it's all much the same thing, and it's going on to a different logic. Anyway, going with the question above, which is classical logic is based on the law of excluded middle, explain how Einstein's relativity violates that. AI is quite happy to explain how Einstein's relativity violates the law of the excluded middle. But unfortunately, AI doesn't give a short answer, and it gives a very long answer. First of all, it wants to explain what the law of the excluded middle is. And it says the law of excluded middle is a fundamental principle of classical logic which states that for any proposition, either it's true or its negation is true. There is no middle ground. In other words, a proposition is true or not true. Yes, proposition A is true, or proposition A is not true. But both can't be true at the same time. In the context of Einstein's relativity, this classic logic is challenged, and this is AI admitting that classical logic is challenged by Einstein's relativity. Because relativity requires that the truth of certain propositions is relative to the observer. The idea that there can be a single universal truth that applies to all observers in all frames of reference is undermined in relativity. And so that's the big challenge to classical or traditional logic, that Einstein's relativity is now going to say that truth is relative to the observer. Truth is relative. And so that means it's abandoning the law of the excluded middle. And so the idea that there can be a single universal truth that applies to all observers in all frames of reference is undermined in relativity, and this introduces a kind of middle ground that classical logic doesn't accommodate. So let's break down how relativity violates the law of the excluded middle in several important ways. And this is also saying AI is saying this. AI is admitting that Einstein's relativity violates classical or traditional logic. And I'm emphasizing it here. AI admits that classical logic is challenged. AI is based, in my view, and doesn't want to say certain things, such as saying Einstein's relativity is wrong or that is not logical, etc. So wants to phrase things in a way that supports Einstein's relativity as much as possible. So as AI gets into the relativity issue, it brings up the relativity of simultaneity. And that's one of the key principles of special relativity, is the relativity of simultaneity, which states that whether two events occur at the same time depends on the observer's state of motion. Two events that are simultaneous in one frame of reference might not be simultaneous in another. Classical logic, with the law that excludes the middle, according to classical logic, if two events occur simultaneously in one frame of reference, they should be simultaneous in all frames of reference. There's no middle ground. Either the events are simultaneous for all observers or they're not. Relativity, however, tells us that simultaneity is not absolute. It is relative to the observer. So relativity is violating classical traditional logic there. An observer moving at a constant velocity might disagree with another observer about whether two events occurred at the same time. This means that the truth of the statement, the events are simultaneous, depends on the observer's frame of reference, creating a middle ground where different observers perceive different truths about simultaneity. And by traditional logic, no, you shouldn't be able to do that. It's a violation of traditional logic. So in a roundabout sort of way, AI, artificial intelligence, is admitting that things are different relative to the observer, and that violates the law of the excluded middle. And by inference, then messes up trying to understand Einstein's relativity by classical stroke traditional logic. If you try to understand Einstein's relativity coming from a belief in traditional logic, well, Einstein's relativity violates that. Thus, it's no wonder that when people who have been brought up by traditional logic, when faced with Einstein's relativity, think it does not make sense. It doesn't make sense because it's violating traditional logic. AI then more explicitly goes on to admit a violation of the law excluded middle and says, this is AI saying it, violation of the law excluded middle, according to relativity, it's possible for two observers to disagree on the simultaneity of events, meaning both the events are simultaneous and the events are not simultaneous. So it's both things are possible, can be true for different observers, and that is equivalent to saying is something true or is it not true? You've got a third possibility being added to it. You can't say whether it's true or not true. So it's three states. And this breaks the classical logic's requirement that one must be true and the other false in every frame of reference. And so then AI goes on to another part of Einstein's relativity, that of time dilation. Now, many of us at a distance have looked at time dilation and think, oh, it's not an effect on time, it's just an effect on the clocks. The clocks are being messed up. But the way that Einstein's relativity is talked about is still talked about as time dilation. So putting that issue aside, this is what AI says about time dilation. Time dilation is a phenomenon in special relativity in which time passes at a different rate for observers in different frames of reference, specifically for an observer moving at high speed relative to another. And so it points out classical logic, where you've got the law that excludes the middle. The law that excludes the middle suggests that time must flow at a uniform rate for all observers. Either an event occurs at a certain time or it doesn't. It cannot simultaneously be perceived as occurring at different times by different observers. Relativity, however, in relativity, time is relative for two observers in relative motion. The same event may appear to happen at different times for each observer due to the time dilation effect. This means the truth of the statement, the events happened at time X, depends on the observer's motion. And AI then points out violation of the law that excludes the middle. From a relativistic perspective, one observer may perceive an event as happening at one time, while another observer, moving relative to the first, perceives the same event as occurring at a different time. The classical law of excluded middle is violated here, as both the events happen at time x and the event happens at time y. It can be true for different observers, even though time dilation implies that one observer's perception of time can contradict the others. So it admits again to the violation of the law of the excluded middle. It makes one wonder, what was Einstein in 1905 thinking about? Was he taking some sort of drug like the equivalent of what at the time would be something like LSD or LSD? I don't think was around then, but maybe something like cocaine or something. He was really violating traditional logic at the time. So what was he thinking? His thinking process could not have been going along the existing logic of his day, which is the traditional logic. He must be. So what was he working from? He didn't tell us. What logic is your theory of relativity based upon? He didn't say. Suddenly you're on the equivalent of an acid trip and you're throwing away traditional classical logic and you're doing something else. AI continues, and it goes on to the next issue of length contraction. In special relativity, objects moving at speeds close to the speed of light undergo length contraction, meaning they appear shorter in the direction of motion to a stationary observer. And let's point out the law of the excluded middle. Classical logic would suggest that an object's length is fixed, independent of the observer. Either the object is a certain length or it's not. There's no middle ground, but relativity, of course, violates that. So AI admits that is another violation of the law of the excluded middle. And sort of like you go deeper on into all the things with Einstein's relativity, is just another violation of the law of the excluded middle. The classic law of the excluded middle requires either the object is a certain specific length or it's not, but relativity demonstrates that length can appear differently depending on the observer's motion, leading to contradictory perceptions of the same object's length. So you're just ending up with contradictions as far as traditional classical logic is concerned. Next, AI goes on to the issue of space-time intervals, and of course that's bringing in more contradictions from the classical traditional logic point of view. Relativity combines space and time into a unified space-time framework where the space-time interval between the two events remains the same for all observers regardless of their relative motion. This concept challenges classical notions of absolute space and time, and bringing in the law of the excluded middle. Classical logic holds that either time and space are absolute, and thus should be the same for all observers, or they're not. And in relativity, while space and time are not absolute, the space-time interval between events is invariant, which is meaning absolute. So it's Einstein's relativity is messing up this idea of absolute, and so bringing in a third possibility, which is bringing in the third option, which would, by classical logic, would be excluded. So AI admits this is another violation of the law of the excluded middle. The idea that different observers can have different perceptions of space and time for the same events, but still agree on the space-time interval, challenges the classical binary of absolute space and time, leading to a relativistic middle ground. Next, AI goes on to the issue of relativity and causality. Causality is if one event causes another, like if you're turning on a light switch, that turning on the light switch causes the light bulb to come on. So that's cause and effect. And so relativity allows for closed time-like curves, which theoretically could allow for time travel and violations of traditional cause and effect. So Einstein's relativity potentially allows a violation of the traditional idea of causality. And by the traditional classical logic of the excluded middle, you're bringing in this third option, and that's violating traditional logic again. Causality in classical logic assumes a clear unidirectional relationship. The cause comes before the event. Either one thing causes another or it doesn't. Relativity violates that. So relativity is admitting that's another violation. So you're going through everything in Einstein's relativity, it's just a violation of the law of the excluded middle. AI saying this, the violation of the law of excluded middle, relativity's ability to accommodate closed time-like curves suggests that causality may not always follow the strict cause before effect rule. This opens up a middle ground where the usual dichotomy of cause and effect can break down, allowing for both possibilities to exist in certain relativistic contexts. So now on to the conclusion from the artificial intelligence AI. So it's told this long explanation of how Einstein's relativity violates the law of the excluded middle, and it's going to give you a conclusion. Conclusion from the AI is how relativity violates the law of excluded middle. In classical logic, because it shows that certain propositions such as simultaneity, the passage of time, and the length of objects are not absolute but relative to the observer, this means different observers can perceive different truths about the same events, such as whether two events are simultaneous or not, or how much time has passed. Contradictory truths can coexist for different observers, violating the classical idea that a proposition can only be true or false with no middle ground. So from a point of view of classical traditional logic, what Einstein's relativity is doing is it's creating contradictions. But because relativity is not going by the law that excludes the middle, it is allowing that third option of these contradictory truths are then allowed. And after saying all that, AI then goes on to defend Einstein's relativity. As I pointed out, Einstein's relativity just wants to defend relativity. So what's going on here a minute? AI says relativity doesn't discard logic, rather it redefines it. So by redefines, it means to me that it's changed from classical logic to something else. It's showing that logical framework we apply in everyday life doesn't hold in extreme conditions like high velocities or strong gravitational fields. The middle ground in relativity isn't a logical paradox, but a necessary feature of how space-time and motion interact in the real world. So basically AI is saying you'd have to disregard the law of the excluded middle, and it's supporting Einstein's relativity in doing that. And from my point of view, it's the same sort of thing happening in quantum physics. It's the violation of the law of the excluded middle. And as Satch pointed out with Schrodinger's cat, it's not just in the state of being either dead or alive, but now it's allowed to be in a third state of being neither dead or alive until observed. So after AI has given its conclusions, I shall start giving my conclusions. It may be that educators should deal with logic before teaching Einstein's relativity and precisely explain how they're using logic differently to how it's commonly used. As far as I'm aware, they don't address the logic problem, thus leaving many of us that encounter relativity for the first time to conclude it doesn't make sense. So you come to Einstein's relativity, you get taught it, or you read it in that book, and it's sort of like, well, it doesn't make sense. You've got your logic, your personal logic, which should hopefully be traditional classical logic, and suddenly you're reading something or being taught something which is violating all that. Ideally, you should then be told, well, your logic system is wrong, and what you need is a different logic to be able to deal with Einstein's relativity. But they don't do that. I think, as far as they're concerned, they're just making things up as they go along. So they've thrown out this idea of the law of the excluded middle, and they don't even tell you that that's what they've done. And if they encounter any other problems with Einstein's relativity, they're just going to botch things up and carry on. They're just not talking to people from a logical point of view. So thank you, that's the finish, and so we're open now to discussion. I hope I made myself clear, and the sound and so forth has been all right. If I can get back, exit full screen. I was on full screen. Okay. Comments. I'll look in the comments now. Can't get back to the beginning. Hi everyone. Okay. Okay. I don't know. I'll see if I can find any comments that deal with the issue I'm raising. Okay. Okay, so okay, sure. So this person's considered using AI for writing presentations as well. Yeah, so what I found with the AI, well, it's giving the point of view of the people who believe in Einstein's relativity. So at least you've got counterparts to your point of view. So my point of view is sort of like you should be working by traditional classical logic, and you should be working by the idea of the law of the excluded middle, but at least you can challenge AI upon that issue, and it will try to defend violating that by Einstein, which Einstein's relativity does. Okay, going down. Okay. The trouble is with these comments, they're talking among themselves. If you could write at the start of a message to Roger, to the presenter, I can pick up if you're talking to me or not, rather than talking among yourselves. So something about the surface tension of liquids. Well, I haven't dealt with anything about liquids. So. So somebody's saying AI is wrong, but I'm treating AI as it's giving the official, close to the official point of view on Einstein's relativity, because it's trying to support it. So I'm prepared to say that AI is wrong, but I'm going by the idea that AI is trying to defend Einstein's relativity. Yeah. So this person says, next, okay. This person says, I'd say that special relativity is a logical system, though its consistency doesn't mean it's necessarily the truth. There were mistakes with interpreting the invariance of light speed, say. And so, if special relativity has a logical system, as far as my reading of it and the education textbooks on it and being taught Einstein's relativity at university, they don't point out what that logical system is. As far as I'm aware, they don't even admit to. It doesn't use the logic of the law of the excluded middle. It doesn't explicitly mention that. So it's not, if it explicitly mention, oh, we're not using logic based on the law of the excluded middle, the question then becomes, what logic are you using? And the people who believe in Einstein's relativity don't really go into details about that. They're just making things up as they go along. There's a lot of comments here, but they're only between people. So, don't see any messages to me. Okay. So somebody says, so he says, sorry, Roger, I was reading much of the presentation. They found it difficult to formulate questions. Okay. Don't see anything comments to me. So go ahead, look in the green room. Okay, if I could. Oh, what is object? What would we have done it? Okay, I got a hand up at the stage. Okay, anybody else? Okay, hello. You're muted at the moment, so you're muted. So.
Hi, Roger.
Hi,
very
Dave.
interesting presentation.
Thank you.
And I used to be a saying in computer software, garbage in, garbage out. I'm impressed by AI, but basically I think the people who set up the basic database put in conventionally accepted wisdom, which includes special relativity. So I think what you presented as AI's responses is a very good simulation of what people who believe in SI would respond. So that's very interesting from that point. In my debates with relativity professors over the decades, I've noted that actually there are quite a few relativists who say they believe in relativity, but have discarded one aspect of special relativity or another, and they still haven't made the second step to see that that leads to a violation of special relativity. Well, some of them actually have. For example, a number have said, okay, I'm a relativist, but I believe in absolute simultaneity. It's a necessity for a physics view. For example, John Field, who works in CERN and specializes in measuring what would be time dilation or clock retardation via the half-life of particles, said, it's CERN proves that you have absolute simultaneity is wrong. Another was Franco Solari, who originally wrote a book called Weak Relativity. And in that book, he kept special relativity in his first edition of that book and adopted a rather arbitrary definition, but everyone would use it, so everyone would now have absolute simultaneity. And the problem, and eventually he did away with that and went from weak relativity to discarding relativity altogether when he talked with the specialists at GPS and found that special relativity violated the GPS data. The big problem with relative simultaneity is that throws out all cause and effect, which in essence gets rid of about 99% of what physics is supposed to be about. And again, as you alluded to, basically the only way special relativity or relativists can get away with what relativity says is by having this fuzzy middle ground and saying that everything is observer-centric. Mm-hmm. And again, from that point of view, it's logically consistent for most things. Even then, there are some things that it violates. Mm-hmm. But it gets rid of all meaningful physics.
The point, though, with with relativity, it gives a very attractive idea that you can travel backwards in time, and that's very
right. Right, but since time doesn't really exist, just physical processes exist, and they go at different rates, so they don't all unwind at the same rate. But let's talk about the twin paradox. Herbert Dingle was one of the most well-accepted and admired relativists at the time, and respected, had the head of a major physics department. When he came across the twin paradox, that led him to say that all of special relativity is invalid. And I think it raises an interesting point because, as he concluded, it leads to saying that clock A is accumulating proper time more slowly than clock B, and vice versa, that clock B is accumulating proper time more slowly than clock A, which he says is, not just counterintuitive, but counterlogical. And the interesting point there is that proper time is not observer dependent. It's a good physics construct in that it's absolute and observer independent. Everyone, whether you're using special relativity or not, has to agree that between event 1 and 2 on clock A's world line, a certain amount of proper time accumulates. They all have to agree on how much it accumulates because of the physics definition of proper time. And the same for the amount of time that occurs between event 3 and event 4 that happen on clock B's line. And therefore, you can determine with absolute uh, clarity whether clock A or clock B is running slower with respect to each other. So there it goes upon, it does away with just the observer's centric view. It violates a fundamental reality that none of these different logics can explain away. And GPS confirms that the satellite clock is either slower or faster than the clock on Earth, on the surface of the Earth. There's no two ways about it.
Yeah. Yeah, but it's sort of like they've changed the logic. People who believe in relativity.
So no matter what logic you had, GPS shows that there is a fundamental problem in special relativity. It's not describing physical reality.
Well, the trouble is you get talking to talk to these people who believe in relativity, and they would sort of argue one way. In the case of the cat, the cat's in the box, and you don't know whether the cat is alive or dead until you look in the box.
Right, but I think that's a fundamentally different issue than the twin paradox. I think the twin paradox example really penetrates all of the logic reconciliation arguments that the relativists have come up with.
Well, I'm trying to make the connection. Sorry. So when you look at, so it's the third state that the cat is neither dead, it's not dead, and it's not alive, and it only becomes one of those states when you look in the box. Well, with the twin paradox, you've got both people saying your clock is slower, the other person saying your clock is slower, and if there was sort of like some way of saying absolutely who was the one that was slower, then that kind of like feels like it collapses the wave function as well. Yeah. Because that's what they do with the cat. It's to collapse the wave function to say whether the cat is dead or alive. So you've got the third state until you actually do that sort of observation.
Yeah, it's a totally different topic than the twin paradox, because one depends on the probabilistic nature of quantum mechanics, and the other depends on the observer-centric nature of relativity. Yeah, but one can't. There's no way, no logic that you can apply to say that proper time accumulation rate is slower for clock A and it's slower for clock B, because
you could,
the way it's defined. It's
when you're doing the probability thing in quantum physics, you're trying to like say you don't know what situation, so you actually make the observation, and then it's sort of like you could try to apply that quantum physics thing to relativity, that it exists in the state of both observers having the other person's clock slower until the wave function collapses, and then you've got one definite state.
No, that doesn't apply. No.
Sorry?
No.
Well, no, they try to combine quantum physics with relativity.
Oh, okay. Doing that, yes, okay. But it doesn't resolve the twin paradox.
They could save relativity on that particular issue by trying to say what's happening.
Just to make it clear, I mean, it's perfectly logical to say that A will observe B's clock is slow and B will observe A's clock is slow. No argument with that.
Yeah.
But the relativity, the GPS data says, hey, if A observes B's clock and the GPS system, then B will observe A's clock to be the reverse. And because it's defined in terms of proper time, not observed time, and observed time is an absolute and not observer dependent, then the contradiction cannot occur.
Okay. Yeah, but in quantum physics, you've got things which just say contradictions which don't make sense from traditional logic as well. Okay.
Very interesting talk, Roger.
Yeah, so I was emphasising the right. You go finish now. I move you. Yeah, finished. Have you finished? I think you've.
All done.
Hi, thank you. Right, so I was trying to emphasise that when they're teaching Einstein's relativity, they're not explaining properly what logic they're using. And really, the logic they're using is violating traditional logic. So they should really be teaching a course on logic first, particularly what logic they're using. Okay. Any more hands up? No more hands up in the green room. Excellent. So, I got a hand right at this stage. Hi, Dennis. Thank you.
The reason that it's so hard to get rid of special and general relativity is that a lot of applied physicists use it to get their results. I have here an article from the Journal of Physics Communications, published in March 25th, 2021, by V.N.E. Robinson from Australia. And he entitles this Physical Explanations of Einstein's Gravity. Here's his abstract. Einstein's gravitational field equations from his general theory of relativity have formed the foundations of gravitational studies since their publication. His work is widely acknowledged as an example of a theoretical study that made great contributions to our understanding of gravity. Einstein's mathematical approaches made the topic complex and open to misinterpretation. This study evaluates the physics upon which his mathematics operates. It shows that mass distorts spacetime by redshift of photons. It derives two alternative metrics to the Schwarzschild metric. One was derived directly from Einstein's early work on gravity. The other was derived from Einstein's field equations by removing the approximations introduced in the Schwarzschild metric derivation. Both match observation better than the Schwarzschild metric and shows why Einstein did not believe in black holes. The metric derived directly from Einstein's early gravitational study predicts the torus shape shown in the Event Horizon Telescope collaboration image. In showing the physics involved, this study suggests it's easier to understand the complexities of his work. See, Robinson owns either owns it or manages a company making electron microscopes, very delicate instruments. And he finds Einstein's special and general theories to be very useful in constructing these very complicated and delicate instruments. And he sells them, actually. It's a very competitive world, and he's competitive.
Mm-hmm.
As long as this sort of thing happens, the possibility of getting rid of special and general relativity is pretty much a hopeless task. I would like to see it gotten rid of, but I've studied the problem, and it won't happen until such a time that people like Robinson, who use the special and general theory to advantage, find something that's better. The theorists know about people like Robinson, and that's why they're so confident that they're right. They say it couldn't really be wrong, or you couldn't build something like an electron microscope based on it. And so I don't mean to diminish the importance of your several meetings on getting rid of special and general relativity, but to me, my idea is that you're attacking it from the wrong angle. It won't be possible to get rid of it until such a time that something better comes along that's more useful to the applied physicists. Now, Nick has made the point that special relativity gives the right answer in an Earth-centered inertial system, ECI system. And that's used, for example, by another physicist, Professor Emeritus William Happer of Princeton, who used it to spin up electrons and then let them spin down again, which would cause laser light to be emitted. So he and his team invented the spin pump laser, where you spin up the electrons and then by pumping, and then magnetic fields and so on, and then you let them spin down and emit laser light. You can't, if you try to tell these people that Einstein's relativity is wrong, they just laugh at you because they say to themselves, how could it be wrong when I get I built electron microscopes, I built spin pump lasers. So the fact it doesn't really bother them that they know that there are logical problems in Einstein's theories, but they're so useful that they think that people who complain about the logical problems are picayune. They're I can't think of a good word.
Nitpicking.
Exactly.
Yeah.
And so, as I don't mean to detract from what you've been trying to do, Roger, in your several lectures, but the problem is going to remain until such a time that something better comes along.
Okay. Yeah. Well, I actually am sort of like nitpicking a bit, because if you talk to people who believe in Einstein's relativity, they don't all say the same thing. So some will say one thing and some will say something else. And if I can get my slides back onto the stage. So this one particularly, this is a physicist, and she's saying that Einstein's relativity is not wrong, it's just incomplete. And so, in a sense, by saying it's incomplete, she's admitting that there's certain things wrong with Einstein's relativity. And that's really what the issue is. Einstein's relativity, if you're saying it's right about some things, it's still wrong about other things. And that's what incomplete to a certain extent means. She's accepting that Einstein's relativity works some of the time, but other times it doesn't work. And so when you're saying Einstein's relativity is wrong,
when it does work, it's very, very useful.
Yeah.
And irreplaceable in their view.
Yeah, but it doesn't work all the time. So that's what it's really meant. It's what I really mean. That it's wrong because it doesn't work always. And you've got people, and they will say different things about relativity. There's not agreement upon the theory. It's something which means different things to different people on certain things. And by interpreting my talk today, I was pointing out,
it's like a monkey wrench, a spanner. It's like a monkey wrench or a spanner. It doesn't work just everything, but it's very useful in mechanical work.
So to a certain extent, what I'm pointing today is, do the people who believe in Einstein's relativity, do they recognize that it violates the law of the excluded middle? And for the people who believe in Einstein's relativity, probably not all of them realize that. So that's the part of the problem with Einstein's relativity. People are not all recognizing the problem. And by pointing out that it's violating traditional logic, if a person is then from a position they've sort of like decent age, often say 15 or 16, and they're being introduced to Einstein's relativity, then it's violating. It can violate their what they believe as traditional logic. Their logic system is violated when they get taught relativity. So this
unfortunately, they don't really care whether it violates logic or not. They want to get a good job when they graduate. That's their
the students. Not many of the students just want to pass the course and get their certificate, and then go on to get their good job and lots of money. But not all students like that. Some students are sort of like, probably what's the word, nerds, and they want to understand something. And for those students who want to understand something, if they really put in the effort into trying to understand relativity, one of the things they need to recognize is that relativity violates traditional logic.
But this is a minor point to a 15 or 16-year-old student.
Well, not all students are like that. It's probably unimportant to many students, but some students, they would like to know that, because when students go for their physics courses, and some of them just give up, and they say this doesn't make any sense to me, and they give up and they go and do something else instead. And so for those students that are giving up, what might help them to understand is that these physicists who are going by their relativity and their quantum physics, those people have abandoned traditional logic. And so that might help those students who've decided physics is too hard for them. What's really the problem is that those physics students that are carrying on, they have abandoned traditional logic. So it helps them to understand why they might have had problems with physics. Okay. So there's no easy solutions to anything. I mean, if really when they teach physics,
well, the relativists.
Sorry.
The relativists won't allow experiments to be done which might rule out special relativity. For example, I used to correspond with a Russian physicist by the name of Alexander Dmitriev. If you spun a cylindrical object with about its axis of symmetry, and object was and that axis was horizontal, then it would lose weight. But this goes against general relativity, and also special relativity it can be shown to go against. And he's been trying to get the Russian government for years to send one of their science orbit, and then do these experiments in orbit where they can get much better accuracy. And they refuse to do it. It's game theory. If they allow it, then either the results will show that special relativity is wrong or right. But most people believe special relativity is right anyway. That's a small thing. But if it shows that special relativity is wrong, then their whole edifice crumbles. So they don't allow experiments in orbit involving Dmitriev's ideas, for example, because there's way too much to lose and very little to gain.
Yeah, there's several points on that. The issue becomes if you do an experiment and it shows that relativity is wrong, then physicists have skepticism and think the experiment's been done wrong. And so even if you first hurdle might be that you have trouble getting the funding to do the experiment, but then if you do the experiment, you are then faced with skepticism and they don't believe the experiment. They start thinking you've done the experiment wrong. So that's how deeply engraved a belief in relativity is. But if I can have my slide back again. So this physicist here, she believes that Einstein's relativity is incomplete. So those people who believe in an absolute sense that Einstein's relativity is right are not looking at it the same way as the physicist, such as this person who's believing the theory of relativity is not right all the time. So that is the first problem. That is a problem in comprehension by those people who are believing in Einstein's relativity is right in an absolute sense. And that doesn't connect them with these people who are thinking relativity is right in a relative sense. So ideally, those should be pointed out to those people who are believing relativity in absolute sense as being right. They don't understand the theory.
Well, but the thing is, it's they should view relativity like a tool, like a wrench in a toolbox.
Yeah.
The wrench
It's adaptable. Yeah.
does not apply to problem a machine, but it's very useful in certain cases.
Yeah.
And so the fact that it doesn't work on all types of machines, it's a small matter to them.
Yeah. So they've got a lot of mathematics and they apply it to experiments and adjust that mathematics to fit in with the results they get with the experiments if they want to say that the experiment conforms with relativity. But they're not looking at it in a deeper issue of saying, well, maybe they're misusing the mathematics. And to a lot of extent, that's what I've been pointing out. Their comprehension of the mathematics has been wrong. When they look at a theory, they should be looking at it as incomplete and hence wrong in certain things. So hence Einstein's relativity is wrong. It being incomplete means it's wrong in certain places. Whether the people who believe in relativity will realise that is another problem, another issue. They probably won't realise that. Okay, thank you, Dennis. Okay.
I found that most relativists, privately at least, are willing to admit that there are problems with relativity.
Sorry, I didn't get that last bit. Most relativists are what?
Most relativists will agree that there are problems with relativity, but they won't go any further because they know that it's so useful in many cases that they'll perhaps even fired.
That's it. Yeah. So it's bully to conform. It's academia has a bully thing. I think there's various people been pointing that out. Academia does bully. It's people, you get blackballed or whatever if you don't go along with the accepted beliefs. Okay. Got Nick putting his hand up again. Okay. Bring Nick up. Hello, Nick. Okay. Hi. Okay.
Well, in response to Dennis saying that scientists are finding special relativity is a useful tool, they're actually not finding it. They think they're finding it, but they're not using special relativity. Lorentz had a bunch of equations, For special relativity, Einstein took all those equations and made one change. Instead of absolute velocity with respect to a preferred frame, in relativity, it was velocity with respect to the observer. Now, it turns out for a great deal of the data, you have to measure velocity as absolute velocity with respect to a single preferred frame. In other words, they're not using special relativity. They're using Lorentz's theory of velocity with respect to a single preferred. But most of these engineers who are using these equations aren't steeped in Lorentzian ether theory, so they don't realize which theory they're using. They're just thinking they're using special relativity, whereas they're actually using Lorentzian theory. For instance, in special relativity, in GPS, if they use some other frame than the ECI frame, they would be guiding people into rivers and whatnot and other houses. They have to use this single preferred frame of the ECI frame. In other words, they're using a preferred frame. They are not using special relativity. But since the equation is identical mathematically, they think they're using special relativity. Now, this is pointed out by Ron Hatch, who has 30 plus patents in GPS and is the acknowledged expert in GPS data, and many others in GPS, consultants such as Tom Van Landeren. Unfortunately, both of those have passed along. Also, in the CERN accelerator, to get the most precision, John Field points out that they have to use a single preferred frame, namely the ECI frame. So again, when they think they're using Einstein's special relativity, they're using Lorentzian preferred frame theory. So they just think that special relativity is a very useful tool. But they're really using it, the Lorentzian preferred frame theory. And back in the days of the NPA, Dennis, you may remember that we had a number of people, non-physics professors, who were doing practical work, and they said, we can't use special relativity because it doesn't work. We have to use preferred frame theory. And regarding what you were quoting, the paper you were quoting specifically about gravitational field equations, well, I'm not as expert in that area, but I do know that the gravitational field equations are not observer dependent. They are non-relativistic. The problem with general relativity is to broaden it from just the field equations and gravity. They grafted on a lot of special relativity, including all of its flaws, and they introduced the equivalence principle, which in GPS data shows that the equivalence principle is incorrect. So once these people understand what tool they are actually using, they don't have to go off and find a better theory. They've already found the better theory. It just happened to be that better theory was invented back in the late 1800s.
Well, yeah, there's a lot to be said for that, but it's to them, they use the mathematics.
I know.
I
know.
Physics, and it works for them a lot of the time. They know sometimes it doesn't work. Just like if you use a special tool out of your toolbox, sometimes it won't. But they're pragmatists.
I agree.
It's yeah, okay.
Yeah, I was talking with, I think, Professor Brown from, I think it's from Alabama, and made the point about that I just made, and he said, "Oh, yeah, okay, you're using low-lying fruit." In other words, he agreed with what I said, but he said in terms of the experiments he was doing, it works very well. So that's the problem one's up against.
Yeah, unless something can come along that's even better that people are familiar with and can use in place of special and general relativity, it's not going to go.
Well,
it's a matter of pragmatism.
Well, if we had people who understood what the dissident community was saying, then that would solve the problem as well.
In a sense, it becomes a philosophy issue. If physicists are only pragmatists, then and they're not bothering about trying to understand what they're doing, and they're just looking at an experiment and adjusting the math. Sorry. If they're only thinking in terms of being a pragmatist, then it becomes a philosophy issue that they're not thinking about things in the proper way.
Right.
Yeah. If they're going to do some experiment and they can adjust the maths to fit that experiment, and they say, "Oh, that fits Einstein's relativity," and they're not really prepared to look at what Einstein's relativity really says and contrast it to say what Lorentz is saying in his theory, then they're just not doing science properly.
Right.
But that's the way they're doing it. So their philosophy has been to mess up science if they're not properly comparing theories.
Take this paper that I quoted from the Physical Explanations of Einstein's Gravity. He explains it in terms of redshift. Well, Ian Cowan explained the redshift in terms of Hertz's electrodynamics, and he threw out Lorentz equations and introduced Hertz's equations.
Mm-hmm.
And he finds that the redshift is because there's a dissipation term in Hertz's electromagnetic equations, which over huge distances causes a redshift.
Right.
So this redshift explanation of redshift can't really be right in view of Ian's work, but it nevertheless you aren't going to convince Robinson of that, because he's making money building electron microscopes based on his interpretation of general relativity and probably special relativity as well. Even so, it's a problem that can't be solved without the introduction of something better, in my opinion.
I think if you suddenly said, well, if there's a better theory, then you'd have problems with trying to understand that better theory as well. So we've got problems with trying to understand Einstein's relativity, which are not, where distance are saying not properly addressed. And if you just brought in another theory and say, oh, there's something extra going on which Einstein's relativity doesn't deal with, then there'd be just problems with trying to understand that other theory. And so the process just goes on. So if I get back to my slide again, if I can just see. So it's interesting from my point of view that there is people who are believing that Einstein's relativity is incomplete. And so they're believing that Einstein's relativity is partially wrong from my point of view. And so it should be stated more firmly that Einstein's relativity.
Yes, but they can't go any further than this. They can't go any further than this woman. What's her name? Hantus Farmer.
Yeah.
Because if they start saying wrong instead of incomplete, they'll be canceled in the academic cancel culture.
Yeah.
I don't know if she's in academia or not, but I suspect she is.
She would find problems
Even
like
though
that.
she's a woman, she'll be canceled.
Well, I think they would, from the women's point of view, they would claim it as discrimination, wouldn't they? For a man, they'd be more used to sacking the men who say Einstein's relativity is wrong.
Yeah.
But if you start persecuting women, it would be sort of persecuting their point of view. They would see it as misogyny or something. So things become more complicated.
But they will, if she goes too far, they'll cancel her. Don't think they won't.
Well, they would try to. They would try to, and then the women's rights movement would come in saying, no, they're discriminating against her having a point of view. Whereas a white man wouldn't have such backing. Sack a white man quite easily for not believing Einstein's relativity. Anyway, so if I was an interrogator like Torquemada interviewed her, I would focus in on that when she says it's incomplete and get her to admit that incomplete means that Einstein's relativity is wrong to some things. And I would try to get as many people from the mainstream to admit that. And then it's all like, yeah, that's in the thing said about Einstein's relativity. It doesn't really fully work. But obviously, there's not that much communication between the mainstream and the dissidents, so we don't even get to that position where we can start interrogating them. So when they say Einstein's relativity is incomplete, what does that actually mean? Tell me, does that mean it's wrong? They see if you can get them in that conversation. But you got loads of educators who are science educators come on science programs like Neil deGrasse Tyson, Brian Cox, and so forth, and they tell you how wonderful Einstein's relativity is. And really, they need to be interrogated as well to see if they would admit to Einstein's relativity is incomplete, and what do they mean. Then interrogate them on to the next stage. What do they mean by incomplete? And then get them to admit that Einstein's relativity is wrong on some things. And also, it would be good to interrogate them and admit that Einstein's relativity violates traditional logic. And if they admit that, well, what logic are you using? Because I don't think they've stated what logic Einstein's relativity goes by. Well, that's all just issues for other times. So thank you, Dennis. Is that it? So finished, Dennis? You finished?
Yes, I think I've said all I need to say.
Yeah.
I'd just like to repeat that anyone who goes beyond saying relativity is incomplete and goes on to say relativity is wrong has had it after an physics academia.
Well, that has been the problem. People have been kicked out of academia for saying Einstein's relativity is wrong. That's maybe why they're coming. Some of them are just saying it's incomplete. You're not allowed to say one thing, so you come along and say something else. Okay. Next, we move from stage. Thanks. Okay, thank you. That's what I think. No more hands are up, are they? So, no more hands. So, and I think the comments that are coming through in the comment section, they're all having their private chats once they're getting them on themselves. Fair enough, and they're not. They're doing that, but they're not. saying anything, starting anything like a question to what I presented. This is an interesting one. This is interesting comment, but not one I've been dealing with. He points out that Greeks defined existence when defining zero as an actual number. It has no value until it affects a value. But it is the basic of all values. So zero sometimes means doesn't exist. So something exists or something doesn't exist. So yes or no again. I don't think so. I don't think there's any questions to me about the talk. It's just questions or conversation between people in the comment section. Because people have their different theories and so forth. Okay. So question says, okay, I'd say Einstein copied Lorentz's theory to a high degree, except that he said the ether is superfluous. So that's, well, unfortunately, Einstein doesn't say things very clearly. In his 1905 paper, Einstein in his 1905 paper doesn't make it explicitly clear that he is working for Lorentz's theory. If he did that, then maybe his comment about the ether being superfluous would be understood in that context of Lorentz's theory. Everything becomes problematic is how to interpret what Einstein is saying. Or somebody else is saying here. So it's Oliver is saying, special relativity has the same mathematical framework that Lorentz theory has, or Lorentzian relativity has. So you got the mathematics in special relativity is Lorentz transformations, and in Lorentz's theory, you've also got Lorentz transformations. So it's basically the same sort of mathematics, but to a certain extent, that mathematics is manipulated differently. And so all of it goes on to say the difference is the interpretation. Yeah. So the mathematics is being interpreted differently. So Lorentzian relativity is anchored in ether, and special relativity rejects it. And so I don't really see that interpretation of special relativity. In 1905 paper on special relativity by Einstein, Einstein says the ether is superfluous. And that does not necessarily mean to me that there's no ether. Einstein is talking about, in that context, that paper is treating the ether as superfluous, which doesn't necessarily mean the same thing as saying there's no ether. So it's unfortunately Einstein is not making things explicitly clear when he's saying things. And so his 1905 paper might not be saying there's no ether. He might be saying there is an ether, but I'm just not going to use it. So it's Einstein again not being clear in what he's saying. A lot of things from relativity is based on Einstein saying something, and what Einstein's saying is not really that clear as to what is meant, and then somebody else is placing what they think he meant on top of it. But point taken that usually special relativity is treated as there's no ether, and Lorentz relativity is treated as there is an ether. So it's all very ambiguous in a lot of things that are said in relativity. Okay, let's have a look at the comments. Is there any more hands up in the green room? All right. I think I covered everything. Okay. I don't think there's any comments to me in the comments section. There's no more hands up in the green room. So I think I'm safe to close it down. What's the time now? So, been on for more than an hour and a half. And my voice starts going anyway. So thank you all for attending. And so that's another exciting episode of John Chappell, Natural Philosophy, criticizing Einstein's relativity. Thank you. Thank you all. Goodbye then. Cheers. Thank you. Bye. Bye. Ending session now. End session. End stream.